Solutions to quiz 8 for Math 112. First asked to simplify these trig expressions, these messes here. Okay. One method to do this, the method we've been using in this class, is first change everything into sines and cosines. So express all these trig functions just in terms of sines and cosines. So cosecant of x is the same as 1 over sine of x. I'll just write 1 over sine. Bad notation, but it'll be a little easier to write. Cosine, I can just say, is cosine. Cotangent is cosine over sine. And that whole thing is squared. And then I want to divide that whole thing by cosine. All right, I can do another line here. It might help to think about this cosine as cosine over 1. Because if you do, then what you have is 1 minus, and in parentheses here, I have, well, this is cosine squared over sine. This might be overkill, but I'll write it out. 1 minus sine over cosine squared minus sine squared over cosine. And the reason you want to do that is because now with the common denominator, we can just write, we got 1 minus cosine squared over sine. And make sure you get that whole thing squared divided by cosine. Let's see, what's the easiest way to do this? I guess 1 minus cosine squared, turns out that that's just the same as sine squared. What I have in the parentheses here is really just sine squared over sine. Then the whole thing is squared over cosine. Maybe I need to justify that step a little bit. To justify that, I'm going to write out the Pythagorean identity up here. It's that sine squared of an angle plus cosine squared of an angle is equal to 1. So if you subtract cosine squared from both sides, you get sine squared is 1 minus cosine squared. So this 1 minus cosine squared thing is just sine squared. Anyways, now sine squared and sine, that'll cancel out. Sine squared divided by sine is just sine. So I get 1 minus, in the parentheses I have sine, but the parentheses are squared, divided by cosine. And then I can apply this mess again. If I subtract sine squared from both sides, I get cosine squared equals 1 minus sine squared. And so my final answer is that whole mess just simplifies down to cosine of x. And for the second one, all right, and then this second one, got this negative out in front. That'd be easy to forget. Anyways, cosecant is the same as 1 over sine. So this is 1 over sine, in other words, 1 over sine squared minus 1 divided by cotangent is cosine over sine. I'll write it out, cosine over sine times sine. So that's going to cancel out nicely. And then down on the bottom of that, I got cosine squared minus 1. Cosine squared minus 1 is the same as negative sine squared. So really what I have is, if I made this sine squared over sine squared, I got 1 minus sine squared all over sine squared divided by, and then this is just cosine, and then this is negative sine squared, and still got this negative out in front of everything. And then this will I'll do one more step and then it'll simplify pretty nicely. 1 minus sine squared, that's just cosine squared. So I got cosine squared over sine squared. Got this minus out in front. Well, how about I take this minus and cancel them out? And then instead of dividing, I can multiply. I got a sine squared over cosine. Maybe I'll put the negatives in and then get rid of them in the next step. Anyways, the sine squareds cancel, the negatives cancel, the cosine squareds cancel. We're left with just cosine of x. So the answer to each of them is cosine of x. These two things are equal to each other. All right, number 2. This one's a little bit trickier, or longer anyways. what we want to do is express the cosine of this difference without using any trig functions. And the trick to it is this angle subtraction formula. So what I'm saying is if you think of arcsine as A, arcsine of X, and arctangent of Y is B, then what I have here, what the question's asking for is what's the cosine of A minus B. And the cosine of A minus B is given by this formula. It's the cosine of arcsine of X times the cosine of whatever B is, arctangent of X, or arctangent of Y apparently, plus the sine of whatever A is, A being arcsine of X, times the sine of whatever B is, arctangent of Y. All right, and then to figure out these four things, I guess I can do them out down here. I want to know the cosine of the arcsine of X. And I can figure that out if I let arcsine of X, if I give it a name. Arcsine of X, maybe call it T. I know I called it A earlier, but don't get confused. I'll call it T down here. And then I take the sine of both sides of this equation, then I get an X, or maybe I'll write it as X over 1, so it's a fraction, is equal to the sine of T. And if X is equal to the sine, or X over 1 equals the sine of T, that means that if I drew this triangle right here, this right triangle, I'll try a little better, and I put T down here, and I know that the sine of T, sine is opposite over hypotenuse, so this has got to be an X and this has got to be a 1. And this thing right here that I could solve for, I've used a lot of letters. Maybe I'll call it C. Sure. I know that C squared plus X squared has got to be 1 squared, which is 1. So C squared has got to be 1 minus X squared. So C has got to be the square root of 1 minus X squared. So what I'm trying to figure out is the cosine of arcsine of X, but really that's just saying what's the cosine of T, because arcsine of X is T, and the cosine of T I can get by looking at this picture. Cosine is adjacent over hypotenuse, so it's the square root of 1 minus X squared over 1. In other words, this mess right here is the square root of 1 minus X squared. 1 down, 4 to go. The good news is that one of these is really easy. Sine of arcsine of X is just X. Those are those are inverse functions of each other. And then I can kind of repeat what I was doing over here, except now I'm going to try to figure out the cosine of arctangent of Y. And the way I'll figure that out is I will give this arctangent of Y a name. Maybe let arctangent of Y be equal to, how about S? I already used T. So now if I take the tangent of both sides, what I get is that Y over 1 is equal to the tangent of S. So if I were to draw the triangle, try that again, and put my angle S down here, then I know that tangent is opposite over adjacent, so I should have a Y here and a 1 here, and then I also know that this squared plus this squared equals this squared, so this has got to be the square root of 1 plus Y squared. So if you want me to figure out the cosine of the arctangent of Y, because the arctangent of Y is just S, all I have to figure out is what is the cosine of S, and I can figure out the cosine of S by looking down here. Cosine is adjacent over hypotenuse, so this would be adjacent is 1, and hypotenuse is the square root of 1 plus Y squared. So what did I just figure out? Cosine of arctangent, this is 1 divided by square root of 1 plus y squared. And I can figure out this last piece. I could probably squeeze it in here, because if I'm trying to figure out the sine of arctangent of y, but I know that arctangent of y is just s, all I got to do is figure out the sine of s. And the sine of s, sine is opposite over hypotenuse, so it's going to be y divided by the square root of 1 plus y squared. So my answer is this mess here, which I can clean up a little bit. I can say this is the square root of 1 minus x squared divided by the square root of 1 minus y squared plus x times y divided by the square root of 1 plus 1 plus. That's not right. What happened there? Oh, this should have been 1 plus y squared over here. That was supposed to be a plus. 1 plus y squared. And adding these up, they have the same denominator, so it's just xy plus the square root of 1 minus x squared divided by this denominator, which is the square root of 1 plus y squared. Whew, that's finally the end of this quiz.